Beneath the icy crust of Jupiter's moon Europa, a vast ocean churns, potentially hiding the secrets to one of humanity's most profound questions. Are we alone in the universe? This alien ocean, cut off from the sun's life-giving rays, could be home to forms of life unlike anything we've ever seen. Join us as we dive into the mysteries of Europa, explore the cutting-edge science behind the hunt for extraterrestrial life, and uncover why this tiny moon could be the key to answering one of the biggest questions of our time. The enigmatic Europa, a cosmic ice ball. Beneath the vast, icy expanse of Europa, one of Jupiter's moons, lies a hidden secret that has captivated scientists and dreamers alike. This cosmic ice ball, slightly smaller than Earth's moon, harbors a global ocean of liquid water beneath its frozen surface. The ocean is believed to be in contact with a rocky seafloor, creating a tantalizing environment that could potentially support life. Europa's ice shell, which is thought to be around 15 to 25 kilometers thick, is crisscrossed by dark streaks and cracks, hinting at the dynamic processes occurring beneath. These surface features are not just geological curiosities. They are windows into the moon's hidden ocean, offering clues about its composition and potential habitability. The existence of this subsurface ocean is one of the most compelling reasons why Europa is a prime target in the search for life beyond Earth. Liquid water is a crucial ingredient for life as we know it, and Europa has it in abundance. The ocean is likely kept liquid by tidal forces exerted by Jupiter's immense gravity, which flex and squeeze the moon, generating heat through friction. This process, known as tidal heating, is thought to be powerful enough to maintain a liquid ocean beneath Europa's icy surface. Additionally, the ocean may contain essential chemical elements and compounds, such as salts and organic molecules, that could provide the building blocks for life. The interaction between the ocean and the rocky seafloor could also create hydrothermal vents, which on Earth are oases of life in the otherwise inhospitable deep ocean. Europa's icy surface is not just a barrier. It's a record of the moon's geological history and a potential pathway for life to emerge. The surface is covered in a layer of water ice, which is constantly being bombarded by radiation from Jupiter's magnetic field. This radiation can break apart water molecules, creating oxygen and other compounds that could be important for life. Some of these compounds may find their way into the subsurface ocean, providing a source of energy and nutrients for potential life forms. The surface also features chaotic terrain, where large chunks of ice have been disrupted and rearranged, possibly by the upwelling of water from below. These features suggest that there may be a connection between the surface and the subsurface ocean, allowing for the exchange of materials and energy. The search for life on Europa is not just a scientific endeavor. It's a journey of discovery that could redefine our understanding of life in the universe. While we have not yet found definitive evidence of life on Europa, the moon's unique characteristics make it a compelling target for future exploration. Missions like NASA's Europa Clipper, set to launch in the coming years, will conduct detailed studies of the moon's ice shell, ocean, and geology, searching for signs of habitability and, potentially, life. As we continue to explore Europa and unravel its mysteries, we are not just looking for another world. We are searching for a reflection of our own origins and a glimpse into the possibilities of life beyond Earth. Jupiter's moon, a world of its own. Europa, the smallest of Jupiter's 4 Galilean moons, is a celestial body that defies simple classification. It's a world of its own, a place where the surface is a vast, icy plain, crisscrossed by dark streaks and cracks that tell a tale of a dynamic, ever-changing environment. Beneath this frozen crust, scientists strongly suspect, lies a global ocean of liquid water, possibly more than on Earth. This ocean is shielded from the harsh radiation of space by the ice above and the rocky mantle below, making it a tantalizing candidate in the search for extraterrestrial life. The ocean's existence is inferred from a variety of observations. Europa's surface is remarkably smooth, with very few impact craters, suggesting that it's regularly resurfaced by geological activity. Moreover, the moon's slight wobble as it orbits Jupiter hints at a decoupling of the icy crust from the interior, a phenomenon that would be facilitated by a layer of liquid water. Additionally, plumes of water vapor have been observed erupting from Europa's surface, further supporting the idea of a subsurface ocean. The temperature on Europa's surface is incredibly cold, around -260 degrees Fahrenheit, but the ocean below is likely kept liquid by tidal heating, a process where the moon's interior is flexed and heated by Jupiter's immense gravitational pull. Life as we know it requires three key ingredients: liquid water, a source of energy, and certain chemical building blocks. Europa seems to have the first two in abundance. The third, while not yet confirmed, is a subject of intense study. Hydrothermal vents on Earth's ocean floors support complex ecosystems, suggesting that similar vents on Europa's ocean floor could provide the necessary energy and chemicals for life. The radiation that bombards Europa's surface could also drive complex chemical reactions, potentially creating the building blocks of life that could then be transported to the ocean below. While the exact nature of Europa's ocean and its potential habitability remain mysteries, the possibilities are thrilling. Each new discovery about this icy moon brings us one step closer to answering that age-old question: are we alone in the universe? The ice shell, a frozen facade. Beneath the shimmering gaze of Jupiter, Europa, a moon roughly the size of Earth's own moon, pirouettes in an eternal dance. It's a world that beguiles scientists and dreamers alike, cloaked in a thick, icy shell that hides a secret: a vast, global ocean of liquid water. This ice shell, far from being a mere frozen facade, is a dynamic and complex barrier that protects and sustains the ocean beneath. It's a place where temperatures plunge to -260 degrees Fahrenheit, -162 degrees Celsius. Yet life, as we know it, might find a way to thrive. The ice shell isn't uniform. It's a patchwork of ridges, cracks, and chaotic terrain, hinting at the tumultuous forces at play. Some regions are smooth, like freshly fallen snow, while others are scarred by dark streaks and spots, possibly from material welling up from below. This ice isn't just sitting there, it's geologically active. Tidal forces from Jupiter's immense gravity flex and stretch Europa, causing the ice to crack and groan. These forces also generate heat, which could be crucial for maintaining the subsurface ocean and even driving geological activity. Beneath this icy crust, the ocean could be up to 100 miles, 160 kilometers, deep, dwarfing Earth's deepest trenches. It's a dark, alien world, but one that might harbor the ingredients for life. The ice shell acts as a protective blanket, shielding the ocean from harmful radiation and providing a stable environment. Yet, it's not an impenetrable barrier. Cracks and fissures could allow exchange between the surface and the ocean, bringing in nutrients and energy sources. Some scientists even speculate that hydrothermal vents on the ocean floor could provide the necessary energy for life to emerge, much like they do on Earth. The ice shell also holds clues about the ocean's composition. Spectroscopic observations have detected salts and organic compounds on the surface, suggesting that the ocean might be rich in these materials. These compounds could be the building blocks of life, providing the necessary elements for complex chemistry to occur. Moreover, the ice shell's thickness and composition vary, indicating that the ocean might be interacting with the underlying rocky mantle, further enriching the ocean with minerals and nutrients. It's a tantalizing prospect, a world where life, as we know it, could potentially exist, hidden beneath a frozen facade. Beneath the ice, a hidden ocean. Beneath the icy surface of Europa, one of Jupiter's moons, lies a captivating secret: a vast, hidden ocean. This isn't just any body of water. It's a global ocean, possibly containing more liquid water than all of Earth's oceans combined. The ice shell covering this ocean is thought to be around 10 to 15 miles thick, with the ocean itself potentially reaching depths of 60 miles. The sheer scale of this subsurface ocean makes it a tantalizing candidate in the search for extraterrestrial life. The ocean's existence is inferred from a variety of observations. Europa's surface is streaked with dark lines and cracks, which are likely caused by the movement of the icy shell over the underlying ocean. Additionally, observations from spacecraft like NASA's Galileo mission have detected a weak magnetic field around Europa, which is consistent with the presence of a conductive layer, such as a salty ocean, beneath the ice. The ice itself shows signs of geologic activity, with features that suggest it has been disrupted and reformed, possibly due to the movement of the ocean below. One of the most exciting aspects of Europa's ocean is its potential habitability. On Earth, life is found virtually wherever there is liquid water, even in extreme environments like deep-sea hydrothermal vents. Europa's ocean, shielded from harmful radiation by its icy shell, could provide a similar haven for life. Moreover, the ocean is likely in contact with a rocky seafloor, which could provide essential chemicals and minerals for life. Some scientists even speculate that hydrothermal vents on Europa's seafloor could support ecosystems similar to those found on Earth. The study of Europa's ocean is an ongoing endeavor, with several missions planned to explore this enigmatic world further. NASA's Europa Clipper mission, set to launch in the coming years, will perform detailed reconnaissance of Europa and investigate whether the icy moon could harbor conditions suitable for life. The European Space Agency is also planning a mission called JUICE, Jupiter Icy Moons Explorer, which will study Jupiter's icy moons, including Europa. These missions aim to answer fundamental questions about Europa's ocean, its potential habitability, and, perhaps, the existence of life beyond Earth. Tidal forces, Jupiter's gravitational dance. Beneath the icy surface of Europa, one of Jupiter's many moons, lies a vast ocean that could potentially harbor life. This ocean is kept liquid by the incredible power of tidal forces, a gravitational dance between Europa and its massive neighbor, Jupiter. Europa is locked in a tight orbit around Jupiter, and as it circles the gas giant, the planet's immense gravity tugs and squeezes the moon. This constant flexing generates heat through a process called tidal heating, which is thought to keep Europa's subsurface ocean liquid despite the frigid temperatures of the outer solar system. The dance between Europa and Jupiter is a delicate balance of forces. As Europa orbits Jupiter, the side of the moon facing the planet experiences a much stronger gravitational pull than the side facing away. This difference in gravitational forces causes Europa to stretch and compress, like a rubber ball being squeezed and released. This constant flexing generates friction within the moon's interior, creating heat. This heat is what keeps Europa's ocean liquid, even though the surface temperatures are well below freezing. The amount of heat generated by this process is substantial. In fact, it's estimated that Europa's ocean could be as warm as Earth's oceans in some places, making it a potential habitat for life. The tidal forces at play in the Jupiter-Europa system are not unique. In fact, they are a common feature of many planetary systems. However, the sheer scale of the forces involved in the Jupiter-Europa system makes it particularly interesting. Jupiter's gravity is so strong that it can actually distort the shape of Europa, causing it to bulge slightly towards the planet. This bulge, known as a tidal bulge, is a direct result of the gravitational forces at play. The tidal bulge moves around Europa as it orbits Jupiter, causing the moon to flex and generate heat. This process is thought to be one of the key factors that makes Europa such a promising candidate in the search for life beyond Earth. The potential for life on Europa is a tantalizing prospect. The combination of a subsurface ocean, a source of heat, and the right chemical ingredients could create an environment suitable for life. While we have yet to find definitive evidence of life on Europa, the possibility is certainly there. Future missions, such as NASA's Europa Clipper, aim to explore this icy moon in more detail, searching for signs of life and unraveling the mysteries of this fascinating world. The gravitational dance between Jupiter and Europa is not just a spectacular display of celestial mechanics. It's a process that could potentially give rise to life, making it one of the most exciting areas of study in our quest to understand the universe. The ocean's depths, a potential habitat. Europa, one of Jupiter's moons, harbors a vast ocean beneath its icy surface, making it one of the most promising places to search for life beyond Earth. This ocean is believed to be in contact with a rocky seafloor, creating a potentially habitable environment. The depth of Europa's ocean is estimated to be between 62 to 170 miles, 100 to 270 kilometers, which is significantly deeper than Earth's deepest point, the Mariana Trench. The sheer scale of this subsurface ocean is awe-inspiring, offering a staggering volume of liquid water that could support a rich and diverse ecosystem. The ocean's potential habitability is further enhanced by the presence of essential chemical elements and energy sources. Europa's icy surface is bombarded by Jupiter's intense radiation, which can split water molecules into hydrogen and oxygen. These elements can then interact with the rocky seafloor, potentially creating a chemical soup rich in nutrients. Additionally, hydrothermal vents on the seafloor could provide heat and minerals, much like those found in Earth's oceans. These vents support thriving communities of life on our planet, suggesting that similar processes could occur on Europa. Life as we know it requires liquid water, a source of energy, and certain chemical building blocks. Europa seems to possess all these ingredients. The moon's tidal flexing, caused by Jupiter's immense gravitational pull, generates heat within Europa's interior. This heat could keep the subsurface ocean liquid and drive geological activity, such as the movement of nutrients from the seafloor to the ocean's upper layers. Moreover, the interaction between the ocean and the rocky core could lead to the formation of complex organic molecules, which are the precursors to life. The search for life on Europa is not just a scientific endeavor. It's a journey into the unknown, a quest to answer one of humanity's most profound questions. Are we alone in the universe? The ocean beneath Europa's icy surface represents a tantalizing opportunity to explore a potentially habitable environment that is both alien and eerily familiar. As we continue to study this enigmatic moon, we edge closer to uncovering the secrets of its hidden ocean and, perhaps, the secrets of life itself. Life as we know it, the ingredients. Beneath its icy crust, Europa, one of Jupiter's moons, harbors a vast ocean that could hold more than twice the water of all Earth's oceans combined. This ocean is kept liquid by the gravitational tug-of-war between Jupiter and its other moons, which generates heat through tidal forces. The ice shell above is thought to be around 1525 kilometers thick, with the ocean beneath it possibly reaching depths of 100 kilometers. This subsurface ocean is a tantalizing prospect for astrobiologists, as it presents a compelling case for the potential existence of extraterrestrial life. Life as we know it requires three key ingredients: liquid water, energy, and certain chemical building blocks. Europa seems to have the first two in abundance. The liquid water is obvious, hidden beneath the icy surface. Energy comes from the moon's unique position in Jupiter's magnetic field, which creates intense radiation that could drive chemical reactions. Additionally, hydrothermal vents on Europa's ocean floor, similar to those found on Earth, could provide the necessary energy and nutrients for life to thrive. These vents are like underwater hot springs, spewing mineral-rich water that supports diverse ecosystems on Earth. The chemical building blocks of life, such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, are also likely present on Europa. Spectroscopic observations have detected salts and organic compounds on the moon's surface, which could have originated from the subsurface ocean. These compounds are essential for the formation of amino acids, the building blocks of proteins, and other complex molecules necessary for life. The interaction between the ocean and the rocky core could further facilitate the creation of these vital chemicals. Europa's unique environment makes it a prime candidate in the search for life beyond Earth. Water, the universal solvent of life. Beneath the icy surface of Europa, Jupiter's enigmatic moon, lies a vast ocean that could hold more than twice the amount of water found on Earth. This ocean, shielded from the harsh radiation of space by a layer of ice, is a tantalizing prospect for scientists searching for life beyond our planet. Water, often referred to as the universal solvent of life, is a crucial ingredient in the recipe for life as we know it. It dissolves, suspends, and transports a wide range of chemicals, enabling the complex reactions that underpin life. On Earth, life thrives in even the most extreme aquatic environments, from the scalding vents of hydrothermal systems to the frigid waters beneath Antarctic ice. This adaptability suggests that where there's water, there could be life. The ocean on Europa is kept liquid by the immense tidal forces exerted by Jupiter's gravity. These forces cause the moon's icy shell to flex and crack, generating heat through a process known as tidal flexing. This heat, combined with the potential for hydrothermal vents on Europa's ocean floor, could create environments similar to those found in Earth's oceans, where life has been discovered thriving in the absence of sunlight. The chemical composition of Europa's ocean is another intriguing factor. Spectroscopic observations have revealed the presence of salts and possibly even clay-like minerals on the Moon's surface, which may have been deposited by the ocean beneath. These materials could provide the essential elements and nutrients needed to support life. One of the most compelling pieces of evidence for Europa's potential habitability is the presence of plumes of water vapor erupting from its surface. These plumes, observed by the Hubble Space Telescope, suggest that the Moon's ocean is in direct contact with its surface, allowing for the exchange of materials. This exchange could provide a mechanism for delivering energy and nutrients to any potential life forms in the ocean, as well as a means for those life forms to communicate with the surface. Future missions to Europa, such as NASA's Europa Clipper, aim to study these plumes in more detail, as well as the Moon's ice shell and subsurface ocean, to better understand its potential habitability. The search for life on Europa is not just about finding extraterrestrial organisms. It's also about understanding the origins and evolution of life in our solar system. By studying Europa's ocean, scientists hope to gain insights into the conditions that gave rise to life on Earth and the potential for life to exist elsewhere in the universe. The discovery of life on Europa would be a monumental achievement, reshaping our understanding of our place in the cosmos and the potential for life to thrive in even the most extreme environments. It would also raise profound questions about the nature of life and the interconnectedness of all living things. In the meantime, the enigmatic Moon continues to captivate our imagination, beckoning us to explore its icy depths and unlock the secrets of its hidden ocean. Energy sources, fueling potential life. Beneath its icy crust, Europa harbors a vast, salty ocean that could be a haven for life. But for life to exist, it needs more than just liquid water. It needs energy. On Earth, life thrives where there's a reliable source of energy, like sunlight or chemical reactions. Europa, however, is shrouded in perpetual darkness and frigid temperatures. So, where might life find the energy to survive? One tantalizing possibility is hydrothermal vents. On Earth, these deep-sea oases teem with life, fueled by the chemical energy from the vents. Europa's ocean, heated by tidal forces from Jupiter, could have similar hydrothermal activity. Water circulating through the Moon's rocky interior might react with minerals, creating a chemical soup rich in energy. This process, known as chemosynthesis, could provide the energy needed for life to emerge and thrive. Another potential energy source is radiolysis. Europa's surface is bombarded by high-energy radiation from Jupiter. This radiation can split water molecules into hydrogen and oxygen, creating a chemical gradient that could be harnessed by potential life forms. While this process is less efficient than hydrothermal vents, it's a steady source of energy that could sustain simple life forms. Moreover, the interaction between Europa's ocean and its icy crust could also generate energy. As the ice shifts and melts, it could create pockets of briny water rich in dissolved gases and minerals. These pockets could serve as microhabitats, providing energy and nutrients for life. The exact nature of these interactions is still a mystery, but they offer a compelling avenue for further exploration. The hunt for life on Europa is not just about finding water. It's about understanding the intricate dance of energy and chemistry that could make life possible in one of the most extreme environments in our solar system. Chemical building blocks, the essentials. Beneath its icy crust, Europa, one of Jupiter's moons, harbors a vast ocean that could hold more than twice the water of all Earth's oceans combined. This ocean, shielded from the harsh radiation of space, is a tantalizing prospect for astrobiologists searching for life beyond our planet. The chemical building blocks of life, as we know it, are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements form the basis of organic molecules, which are essential for life. On Europa, scientists believe that these elements could be present in abundance, thanks to the Moon's unique environment. The icy surface of Europa is constantly bombarded by Jupiter's radiation, which can break down water molecules into hydrogen and oxygen. These elements can then react with other compounds, potentially creating a rich chemical soup beneath the ice. Additionally, hydrothermal vents on the ocean floor could provide energy and nutrients, much like they do on Earth. These vents support diverse ecosystems, even in the absence of sunlight. If similar processes are occurring on Europa, they could provide the energy needed to drive chemical reactions that lead to life. Life as we know it also requires a source of energy. On Earth, this energy comes from the sun, but in the dark depths of Europa's ocean, it might come from chemical energy. Hydrothermal vents on Earth's ocean floors support complex ecosystems by providing chemical energy through a process called chemosynthesis. If Europa's ocean has similar vents, they could provide the energy needed to support life. The combination of chemical building blocks, energy sources, and liquid water makes Europa a compelling candidate in the search for life beyond Earth. Moreover, recent studies have suggested that Europa's ocean may contain significant amounts of salts and other minerals, which could further enhance its potential for habitability. These minerals could provide essential nutrients for life and could also influence the ocean's chemistry in ways that promote the formation of complex organic molecules. The interplay of these various factors makes Europa a fascinating subject of study, as scientists continue to unravel the mysteries of this enigmatic moon. The hunt for life on Europa is not just about finding extraterrestrial organisms. It's about understanding the fundamental conditions that give rise to life itself. Extremophiles, Earth's toughest life forms. Deep beneath the icy surface of Europa, Jupiter's enigmatic moon, a vast ocean of liquid water might be hiding. This ocean, possibly twice the volume of Earth's, is one of the most promising places to search for extraterrestrial life in our solar system. But how could life survive in such an extreme environment? The answer might lie in the resilience of Earth's own toughest life forms, extremophiles. These remarkable organisms thrive in conditions that would be lethal to most known life. They can survive in scorching hot springs, in the crushing depths of the ocean, or in the frigid waters of Antarctica. Some extremophiles can even withstand the vacuum of space. Their existence challenges our understanding of life's limits and opens up exciting possibilities for life beyond Earth. On Europa, temperatures can drop to -260 degrees Fahrenheit, and the ocean is likely covered by a thick layer of ice. Yet, extremophiles on Earth have shown us that life can adapt to even the most inhospitable environments. Take, for instance, the tardigrade, often called the water bear. This microscopic creature can survive being dried out, exposed to radiation, and even the vacuum of space. It can go without food or water for more than 10 years, entering a state of cryptobiosis. Similarly, certain species of bacteria, like Deinococcus radiodurans, can withstand extreme levels of radiation. It can repair its own DNA, making it one of the most radiation-resistant organisms known. These examples demonstrate the incredible adaptability of life. If life exists on Europa, it might have evolved similar strategies to survive in the moon's harsh conditions. Another fascinating example is the Pompeii worm, which thrives in the scorching waters near hydrothermal vents. It can withstand temperatures up to 176 degrees Fahrenheit, thanks to a symbiotic relationship with heat-resistant bacteria. This worm's existence shows how life can find a way to survive in the most extreme environments. On Europa, hydrothermal vents on the ocean floor could provide the necessary heat and chemicals for life to emerge and thrive. The study of extremophiles on Earth gives us hope that life could exist in the icy depths of Europa, adapting to the unique challenges of its environment. The search for life on Europa is not just a hunt for aliens. It's a quest to understand the true limits of life itself. Europa's extremophiles, a possibility. Beneath the icy surface of Europa, Jupiter's enigmatic moon, a vast ocean of liquid water is believed to exist. This ocean, possibly twice the volume of Earth's, is kept liquid by the immense tidal forces exerted by Jupiter's gravity. The combination of water, essential chemicals, and a possible energy source makes Europa one of the most promising places to search for life in our solar system. Scientists are particularly intrigued by the possibility of extremophiles, organisms that thrive in extreme environments, potentially calling Europa's hidden ocean home. Extremophiles on Earth have been found in some of the most inhospitable places, from the scorching hot springs of Yellowstone to the frigid waters beneath Antarctic ice. These hardy organisms have evolved to survive and even flourish in extreme temperatures, pressures, and chemical environments. If life exists on Europa, it would likely take the form of extremophiles, adapted to the Moon's unique conditions. The ocean beneath Europa's ice is likely cold, dark, and subject to intense radiation from Jupiter. Yet, life finds a way. On Earth, microbes have been discovered in deep-sea vents, where sunlight never reaches, and in highly acidic or alkaline environments. These examples suggest that life could potentially exist in Europa's ocean, drawing energy from chemical reactions rather than sunlight. The search for life on Europa is not just about finding microbes. It's about understanding the potential for life to exist beyond Earth. The discovery of extremophiles on Europa would revolutionize our understanding of biology and the universe. It would show that life can arise and adapt in environments vastly different from Earth's. Scientists are developing missions to explore Europa, including the Europa Clipper, which will conduct detailed reconnaissance of the Moon's surface and subsurface. The hope is that these missions will provide evidence of extremophiles, or at least the conditions necessary for their existence. The possibility of life on Europa is a tantalizing prospect, one that fuels our curiosity and drives our exploration of the cosmos. The ice shell, a protective barrier. Beneath the shimmering glow of Jupiter's reflected light, Europa, one of the gas giant's many moons, harbors a secret that has captivated scientists and dreamers alike. This icy world, slightly smaller than our own moon, is encased in a thick shell of water ice. This ice shell, far from being a mere frozen crust, acts as a protective barrier, shielding the potential for life that might lie beneath. The ice is not uniform. It's a dynamic landscape of ridges, cracks, and chaotic terrain, hinting at the complex processes at play. The ice shell's thickness is a subject of ongoing debate. Estimates suggest it could range from a mere few kilometers to as much as 30 kilometers thick. This variability is crucial because it directly impacts our understanding of the Moon's potential habitability. Where the ice is thinner, the exchange of materials between the surface and the subsurface ocean below could be more frequent. This exchange is vital, as it could transport essential chemicals and energy sources from the surface to the ocean, providing the necessary ingredients for life. Beneath this icy barrier, scientists strongly suspect the presence of a vast, global ocean. This ocean is kept liquid by the immense tidal forces exerted by Jupiter's gravity, which generate heat through a process called tidal flexing. The ice shell plays a pivotal role in this scenario. It insulates the ocean from the cold vacuum of space, maintaining the liquid environment that could potentially host life. Moreover, the ice shell also protects the ocean from harmful radiation, acting as a shield against the intense radiation belt that Jupiter generates. The surface of Europa is a tapestry of ice, with features that suggest a history of geological activity. Dark streaks and reddish-brown patches hint at the presence of minerals and salts that might have been deposited by water from beneath the ice. These features are tantalizing clues, offering glimpses into the processes that might be occurring within the ice shell and the ocean below. The ice shell is not a static, unchanging barrier. It's a dynamic environment, shaped by the forces of nature and the potential for life that lies beneath. Radiation, a harsh environment. Europa, one of Jupiter's largest moons, is a captivating world shrouded in ice, with a vast ocean hidden beneath its frozen surface. This ocean, potentially twice the volume of Earth's, is a tantalizing prospect for astrobiologists searching for extraterrestrial life. However, the environment on Europa is far from hospitable. Radiation is one of the most significant challenges, posing a harsh and relentless assault on the Moon's surface. Jupiter's powerful magnetic field traps charged particles, creating intense radiation belts that bombard Europa. The Moon's distance from Jupiter and its thin oxygen atmosphere offer little protection. The radiation dose on Europa's surface is roughly equivalent to receiving a fatal human radiation exposure in just a few days. This harsh reality makes surface exploration extremely difficult and raises questions about the potential for life to exist in such an environment. Despite the intense radiation, there's a glimmer of hope for life on Europa. The radiation doesn't penetrate deeply, so the subsurface ocean is likely shielded from this harsh barrage. In fact, the radiation might even play a role in creating the necessary ingredients for life. When radiation interacts with Europa's icy surface, it can cause chemical reactions that produce complex molecules, including some that are essential for life as we know it. These molecules could then be transported to the subsurface ocean through cracks and vents in the ice, providing a potential source of energy and nutrients for any life forms that might exist there. Moreover, radiation can also drive the chemistry that might lead to the formation of prebiotic molecules, the building blocks of life. On Earth, similar processes have been observed in extreme environments, such as deep-sea hydrothermal vents, where life thrives despite harsh conditions. If similar processes are occurring on Europa, they could provide a pathway for life to emerge and persist in the Moon's hidden ocean. The radiation, while a significant challenge, might also be a crucial factor in creating the conditions necessary for life. The search for life on Europa is far from straightforward. The harsh radiation environment means that any surface exploration would require robust shielding and careful mission planning. However, the potential payoff is immense. Europa's subsurface ocean represents one of the best opportunities in our solar system to search for extraterrestrial life. Understanding the role of radiation in shaping Europa's environment is a critical step in this quest. It's a reminder that life, if it exists on Europa, would be unlike anything we've encountered before. It would be a testament to the resilience and adaptability of life in the face of extreme conditions. Cryovolcanoes, windows to the interior. Beneath the icy surface of Europa, Jupiter's enigmatic moon, lies a vast ocean that could potentially harbor life. This ocean is shielded from the harsh radiation of space by a thick ice shell, but it's not an impenetrable barrier. Europa's surface is crisscrossed by long, linear fractures and ridges, hinting at a dynamic world beneath. Among the most intriguing features are cryovolcanoes, icy volcanoes that might be windows into Europa's hidden interior. Cryovolcanoes on Europa are thought to erupt with a mix of water vapor, ice particles, and possibly even salts and organic molecules. These eruptions could provide a direct sample of the Moon's subsurface ocean, offering scientists a tantalizing glimpse into its composition and potential habitability. On Earth, volcanoes have played a crucial role in shaping our planet's atmosphere and surface, and they've also been linked to the emergence of life. Similarly, Europa's cryovolcanoes could be key to understanding the Moon's potential to support life. The process behind cryovolcanism is driven by tidal forces exerted by Jupiter's immense gravity. These forces flex and heat Europa's interior, causing the ice shell to melt and creating pockets of liquid water. When pressure builds up, it can force this material to erupt through the ice shell, much like magma does on Earth. The exact mechanisms and triggers for these eruptions are still not fully understood, but studying them could reveal crucial insights into Europa's internal structure and the nature of its subsurface ocean. One of the most exciting aspects of Europa's cryovolcanoes is the possibility that they could be spewing out organic molecules, the building blocks of life as we know it. If these molecules are present in Europa's ocean, they could potentially provide the raw materials for life to emerge. Moreover, the energy released during cryovolcanic eruptions could create localized hotspots, providing the energy needed for life to thrive. While direct evidence of life has yet to be found, the presence of these molecules and energy sources makes Europa one of the most promising places in our solar system to look for extraterrestrial life. Plumes, a direct sample of the ocean. Beneath the icy surface of Europa, one of Jupiter's moons, lies a vast ocean that could potentially harbor life. This ocean is shielded from the harsh radiation of space by the Moon's icy crust, making it a tantalizing target in the search for extraterrestrial life. One of the most exciting discoveries about Europa is the presence of plumes, or geysers, that erupt from its surface. These plumes offer a direct sample of the ocean below, a golden opportunity for scientists to analyze the Moon's potential habitability without even landing on it. The plumes on Europa were first observed by the Hubble Space Telescope. They appear as towering columns of water vapor and ice particles that reach hundreds of miles into space. These eruptions are thought to be caused by tidal forces from Jupiter, which squeeze and stretch Europa, causing its interior to heat up. This heat can melt the ice, creating pockets of liquid water that eventually erupt through cracks in the surface. The plumes provide a glimpse into the composition of Europa's ocean, as they carry with them particles from the water below. Analyzing these plumes could reveal crucial information about the ocean's chemistry and whether it has the right ingredients for life. Scientists are particularly interested in the presence of organic molecules, which are the building blocks of life as we know it. The plumes also offer a way to study the ocean's salinity and pH levels, which can indicate its potential to support life. By studying the plumes, researchers can gather data that would be otherwise difficult to obtain, as drilling through the thick, icy crust to reach the ocean is a significant technological challenge. The search for life on Europa is not just about finding microbial organisms. It's about understanding the potential for life to exist in extreme environments. Europa's ocean is thought to be in contact with a rocky seafloor, which could provide the necessary minerals and energy sources for life to thrive. The plumes offer a direct sample of this environment, allowing scientists to test hypotheses about the moon's habitability. Future missions, such as NASA's Europa Clipper, aim to fly through these plumes and collect data that could revolutionize our understanding of this enigmatic moon and its potential to host life. Future missions, the hunt for life. Europa, one of Jupiter's largest moons, is a captivating world shrouded in ice, with a vast ocean hidden beneath its frozen surface. This ocean, potentially harboring more water than all of Earth's oceans combined, has sparked intense scientific interest and speculation about the possibility of life. Future missions aim to unravel the mysteries of this enigmatic moon, with a primary focus on the hunt for life. NASA's Europa Clipper mission, set to launch in the coming years, will perform flybys of Europa to study its ice shell, ocean, and geology. The spacecraft will carry a suite of advanced instruments designed to analyze the moon's surface and subsurface, searching for signs of habitability and potential biosignatures. One of the most intriguing aspects of Europa is the potential for hydrothermal vents on its ocean floor. On Earth, these vents support diverse ecosystems teeming with life, thriving in the absence of sunlight. If similar vents exist on Europa, they could provide the necessary energy and nutrients for life to emerge and flourish. The Europa Clipper's instruments, such as the Europa Imaging System, EIS, and the Mapping Imaging Spectrometer for Europa, MICE, will map the moon's surface in high resolution, searching for plumes of water vapor that might erupt from the subsurface ocean. These plumes, if detected, could provide direct samples of the ocean's composition, offering tantalizing clues about its potential habitability. The search for life on Europa extends beyond NASA's efforts. The European Space Agency, ESA, is also planning a mission called the Jupiter Icy Moons Explorer, JUICE, which will study Europa, as well as Ganymede and Callisto, two other icy moons of Jupiter. JUICE's instruments will focus on understanding the subsurface oceans of these moons, their potential habitability, and the processes that drive their geological activity. Both Europa Clipper and JUICE represent significant steps forward in our quest to understand the potential for life beyond Earth. As these missions prepare to explore Europa's icy mysteries, the scientific community and the public alike eagerly await the discoveries that lie ahead. The possibility of finding life on Europa is not just a scientific endeavor. It's a journey that speaks to the very essence of human curiosity and our place in the cosmos. Europa Clipper, NASA's upcoming mission. Beneath its icy crust, Europa, one of Jupiter's moons, harbors a global ocean that could hold more than twice the water of Earth's oceans. This ocean, shielded from the harsh radiation of space, is a tantalizing prospect for astrobiologists searching for signs of life. The conditions within this subsurface ocean might be similar to Earth's deep-sea hydrothermal vents, where life thrives in extreme conditions. Europa's ocean is kept liquid by tidal forces from Jupiter, which generate heat through a process called tidal flexing. This heat, combined with the potential for chemical energy sources, makes Europa a prime candidate in the search for life beyond Earth. NASA's upcoming mission, the Europa Clipper, is designed to perform detailed reconnaissance of Europa and investigate whether the icy moon could harbor conditions suitable for life. The spacecraft will orbit Jupiter and conduct multiple close flybys of Europa, using a sophisticated suite of scientific instruments. These instruments include cameras and spectrometers to produce high-resolution images and maps of Europa's surface, an ice-penetrating radar to measure the thickness of the ice shell, and a magnetometer to measure the strength and direction of Europa's magnetic field. By studying the Moon's gravity field, the mission aims to determine the depth and salinity of the subsurface ocean. The Europa Clipper will also search for plumes of water vapor that may be venting from the Moon's surface, which could provide samples of the ocean's composition without the need to drill through the ice. One of the most exciting aspects of the Europa Clipper mission is its potential to detect signs of life, or biosignatures. These could include certain chemicals or patterns that are strongly associated with life as we know it. The mission's instruments will analyze the composition of Europa's surface and any plumes, looking for organic molecules and other potential indicators of life. While the Europa Clipper is not equipped to definitively detect life, it will pave the way for future missions that could directly search for biological signatures. The data collected by the Europa Clipper will also help scientists better understand the habitability of Europa and other icy moons in our solar system. This mission represents a significant step forward in our quest to answer one of humanity's most profound questions: are we alone in the universe? JUICE, ESA's Jupiter Icy Moons Explorer. Beneath the vast, icy crust of Europa, one of Jupiter's many moons, scientists believe there's a hidden ocean. This isn't just any ocean, it's a vast, salty body of water, possibly as deep as 100 miles. The idea of an ocean on a moon might sound like science fiction, but it's a real possibility that has scientists buzzing with excitement. Europa's ocean is kept liquid by the gravitational tug-of-war between Jupiter and its other moons, which generates heat through a process called tidal flexing. This heat prevents the water from freezing solid, creating a potentially habitable environment. The European Space Agency's Jupiter Icy Moons Explorer, affectionately known as JUICE, is on a mission to investigate this intriguing world. JUICE is packed with sophisticated instruments designed to peer beneath Europa's icy surface. One of its key tools is a radar system that can penetrate the ice and map the subsurface ocean. It also carries cameras to capture high-resolution images of the Moon's surface, revealing details about its geology and potential plumes of water vapor. Additionally, JUICE is equipped with sensors to study the Moon's magnetic field and particle environment, which can provide clues about the ocean's composition and potential habitability. The search for life on Europa hinges on understanding the conditions within its ocean. Scientists are particularly interested in the presence of essential elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, which are the building blocks of life as we know it. Europa's ocean is thought to contain these elements, along with a source of energy, possibly from hydrothermal vents on the ocean floor. These vents could provide the necessary energy for life to thrive, much like they do in Earth's deep-sea environments. JUICE's instruments are designed to detect these elements and study the Moon's chemical environment, bringing us closer to answering the age-old question: are we alone in the universe? JUICE's journey to Europa is a testament to human curiosity and ingenuity. The spacecraft will travel over 400 million miles to reach its destination, enduring the harsh radiation environment around Jupiter. Once there, it will spend several years studying Europa and its neighboring icy moons, Ganymede and Callisto. Each of these moons has its own unique characteristics and potential for harboring life. By studying them, JUICE will provide valuable insights into the potential habitability of icy moons throughout our solar system and beyond. The data collected by JUICE could revolutionize our understanding of life in the universe, opening up new possibilities for exploration and discovery. Instruments and technology, the tools of discovery. Beneath the icy surface of Europa, Jupiter's enigmatic moon, lies a vast ocean that could potentially harbor life. To unravel this mystery, scientists have developed an array of sophisticated instruments and technologies. These tools are designed to withstand the harsh radiation and extreme cold of the Jovian system, while providing unprecedented insights into Europa's environment. Among these, radar systems stand out for their ability to penetrate the Moon's icy shell. By bouncing radio waves off subsurface features, These systems can map the thickness and composition of the ice, as well as detect any liquid water beneath. This is crucial for understanding the potential habitability of Europa's ocean. Spectrometers are another key tool in the hunt for life. These instruments analyze the light reflected off Europa's surface to identify chemical compounds. For instance, infrared spectrometers can detect the presence of water ice, salts, and organic molecules. The detection of these molecules is significant because they are the building blocks of life as we know it. By studying the distribution and concentration of these compounds, scientists can infer the processes that might be occurring on and beneath Europa's surface. This data is invaluable for assessing the moon's potential to support life. In addition to remote sensing instruments, scientists are developing advanced probes and landers that could one day explore Europa up close. These robotic explorers would be equipped with cameras, drills, and even small submarines to investigate the moon's icy shell and the ocean beneath. For example, a melt probe could penetrate the ice, collecting samples and measuring the temperature, pressure, and chemical composition of the subsurface environment. Meanwhile, a submarine could explore the ocean itself, searching for signs of life and studying the hydrothermal vents that might provide the energy and nutrients necessary for life to thrive. The data collected by these probes would revolutionize our understanding of Europa and its potential to host life. The search for life on Europa is not just about finding extraterrestrial organisms. It's about understanding the origins and diversity of life in the universe. The instruments and technologies developed for this mission push the boundaries of what is possible, driving innovation in space exploration. Each discovery brings us one step closer to answering one of humanity's most profound questions. Are we alone in the cosmos? The tools of discovery are not just scientific instruments. They are the keys to unlocking the secrets of our solar system and beyond. Data analysis, unraveling Europa's secrets. Europa, one of Jupiter's largest moons, is a captivating world of ice and mystery. Beneath its frozen surface, scientists strongly suspect a vast, hidden ocean of liquid water. This ocean, potentially twice the volume of Earth's, is a tantalizing prospect for astrobiologists. The presence of liquid water is a key ingredient for life as we know it, making Europa one of the most promising places to search for extraterrestrial life in our solar system. But how do we peer beneath that icy shell to uncover its secrets? Data analysis from various missions, particularly the Galileo spacecraft, has provided intriguing clues. Magnetic field measurements suggest that a conductive layer, likely a salty ocean, exists beneath Europa's surface. This ocean may interact with the moon's rocky core, creating a complex chemical environment. Such interactions could lead to the production of energy sources and essential chemicals that might support life. The data also indicates that Europa's ice shell is dynamic, with evidence of geysers or plumes of water vapor erupting from its surface. These plumes, if confirmed, could provide a way to sample the ocean's composition without drilling through the ice. Spectroscopic analysis has revealed the presence of various compounds on Europa's surface, including water ice, salts, and organic molecules. These organics, which are the building blocks of life, could have originated from the ocean below or been delivered by comets and meteorites. The interaction of these organics with the ocean's water and energy sources creates a compelling case for the potential habitability of Europa. Scientists are eager to study these compounds further to understand their origins and implications for life. To unravel Europa's secrets, researchers employ a range of analytical techniques. They study high-resolution images to map the moon's surface features, such as cracks, ridges, and chaotic terrain, which provide insights into the ice shell's dynamics and the ocean's influence. They also analyze the moon's thin atmosphere, which is primarily composed of oxygen, to understand its sources and interactions with the surface. By piecing together these diverse data sets, scientists can build a more comprehensive picture of Europa's environment and its potential to harbor life. The ongoing analysis of existing data, along with future missions like Europa Clipper, promises to shed even more light on this enigmatic moon and its hidden ocean. The search for biosignatures, signs of life. Beneath its icy crust, Europa, one of Jupiter's moons, harbors a global ocean that could hold more than twice the water of Earth's oceans. This ocean, shielded from the harsh radiation of space, is a tantalizing prospect for astrobiologists searching for signs of life beyond our planet. The search for biosignatures, or indicators of life, on Europa is a multifaceted endeavor that combines cutting-edge technology, innovative scientific methods, and a healthy dose of curiosity. Scientists are particularly interested in certain chemicals and patterns that could hint at the presence of life. For instance, they look for molecules like amino acids, which are the building blocks of proteins, and lipids, which form cell membranes. These molecules could be remnants of living organisms or the byproducts of their metabolic processes. Additionally, certain patterns in the distribution and abundance of these molecules can provide clues about potential life forms. For example, an excess of certain isotopes, like carbon-12 over carbon-13, could indicate biological activity, as living organisms tend to prefer the lighter isotope. Another promising avenue in the search for biosignatures is the study of Europa's geysers. These towering plumes of water vapor and ice particles erupt from the moon's surface, offering a glimpse into the hidden ocean below. By analyzing the composition of these geysers, scientists can gather data about the ocean's chemistry without the need for a lander or drill. Instruments like the Hubble Space Telescope have already detected the presence of water vapor in these plumes, and future missions could potentially identify other key biosignatures, such as organic compounds or even complex molecules like proteins. The search for biosignatures on Europa is not just about finding individual molecules or patterns. It's also about understanding the context in which they exist. For example, the presence of certain minerals or the absence of others could provide insights into the geological and chemical processes at work on Europa. Moreover, the interaction between the ocean and the icy crust could create unique environments that foster life. By studying these complex dynamics, scientists hope to paint a more comprehensive picture of Europa's potential habitability. The journey to uncover the secrets of this enigmatic moon is ongoing, and each new discovery brings us one step closer to answering that age-old question: are we alone in the universe? The ethical implications: responsible exploration. Europa, one of Jupiter's moons, is a captivating world covered in a thick layer of ice, with a vast ocean beneath. This ocean, potentially twice the volume of Earth's, is one of the most promising places to search for extraterrestrial life. The possibility of life in Europa's ocean is thrilling, but it also raises complex ethical questions about how we should explore this alien world. Scientists believe that Europa's ocean might harbor life due to the presence of essential ingredients: water, energy, and chemicals. The moon's icy surface is bombarded by radiation from Jupiter, which could create complex molecules. Additionally, hydrothermal vents on the ocean floor might provide energy and nutrients, similar to those on Earth that support diverse ecosystems. However, the very act of exploring Europa to confirm these possibilities comes with responsibilities. We must consider the potential impact of our exploration on any potential life forms and their environment. One of the primary concerns is planetary protection, which aims to prevent contamination of other celestial bodies by Earth microbes and vice versa. This is not just about preserving the pristine conditions of Europa, but also about ensuring that if we find life, we can be certain it is native and not a result of our own contamination. For instance, spacecraft sent to Europa must undergo rigorous sterilization procedures. NASA's upcoming Europa Clipper mission, set to launch in the 2020s, will use innovative technologies to minimize the risk of contamination. The spacecraft will perform multiple flybys of Europa, studying its surface, atmosphere, and subsurface ocean without landing, further reducing the risk of contamination. Another ethical consideration is the potential for resource exploitation. Europa's ocean might contain valuable resources, such as minerals or even water that could be used for future space missions. However, any attempt to exploit these resources must be carefully managed to avoid damaging the moon's environment. International cooperation and clear guidelines are essential to ensure that the exploration of Europa is conducted responsibly and sustainably. The scientific community is actively discussing these issues, developing frameworks to guide future exploration and ensure that the search for life on Europa is conducted with the utmost respect for the potential life forms and their habitat. As we conclude our journey to Europa, let's recap the incredible possibilities that lie beneath its icy surface. This moon, slightly smaller than our own, harbors a vast ocean of liquid water hidden beneath a frozen crust. This ocean is kept liquid by the immense tidal forces exerted by Jupiter, generating heat through a process called tidal flexing. The same forces that create the stunning surface cracks and ridges on Europa also make it one of the most promising places in our solar system to search for extraterrestrial life. Imagine, if you will, the potential for life in this alien ocean. Where there's liquid water, the essential building blocks of life as we know it, there's a chance for life to exist. Europa's ocean is likely salty, and it may contain essential chemicals that could support life. The energy from hydrothermal vents on Europa's ocean floor could provide the necessary conditions for life to thrive, much like the vents found in Earth's own deep oceans. As we look to the future, the mysteries of Europa beckon us. Upcoming missions, like NASA's Europa Clipper, will get us closer than ever to unraveling these secrets. These missions will study Europa's ice shell, its ocean, and its geology in unprecedented detail, bringing us one step closer to answering the age-old question, are we alone in the universe? So, join us on this thrilling journey of discovery. Keep looking up at the night sky with a sense of wonder and curiosity. Who knows what incredible secrets we'll uncover next? Until then, keep exploring, keep questioning, and keep dreaming. The universe is vast, and the possibilities are endless. See you in the next adventure.